Pythagorean Theorem, day 4. We made it. We are on our very last day of learning about the Pythagorean Theorem. Now that we could have spent 10 more days on the Pythagorean Theorem, but that's not stuff that we cover in algebra. You'll be doing a lot more with Pythagorean Theorem in geometry and algebra too. So when we have the converse of something, I'm going to go into what that means just in a minute, but it's when you switch the if and the thens of a statement. And so let's first write down an essential question before we really dive into what do we need to know today. So our essential question is, can I determine if 3 sides make a right triangle? Question, because that's a question, essential question. So, long story short, I need to be able to say, do the sides 4, 5, and 6 make a right triangle? And without drawing anything, without doing any sort of intense geometry, like, okay, what would the angles be? Does it make a right triangle? And we can just plug it into the Pythagorean Theorem and see if it works. Just like a little sidebar, a little side note here, a converse is when you flip-flop the if and the then. So the original Pythagorean Theorem looked like this. If a triangle is right, then a squared plus b squared is equal to c squared. Right? That's how we know that we can use the Pythagorean Theorem. If you give me a right triangle, then I can use the Pythagorean Theorem. But the converse is when you flip it. If a squared plus b squared is equal to c squared, then it's a right triangle. So I'm going to use some colors here. So that converse of the Pythagorean Theorem looks like this. If the Pythagorean Theorem works, then it's a right triangle. So that's how we're going to actually do this part. I know you can't really see that, but I didn't draw anything. It was just like me highlighting. So if you can't see that, I apologize. I was just highlighting those pieces. That the converse of the Pythagorean Theorem says if I plug in everything and it works, then it is a right triangle. So let's see what that looks like. Let's try a problem. Example 1. Are 3, 4, and 5 side lengths of a right triangle? Holy moly, I'm really running out of room there. There we go. Are those side lengths, do they create a right triangle? You are going to plug them into the Pythagorean Theorem, and if it works, if they are equal, if that is an equal statement, then it's a right triangle. So we're going to plug in A, B, and C. Now, which one is C? This is the only thing that matters. Is 3 going to be C? Is 4 going to be C? Or is 5 going to be C? 5 is going to be C, not because it's last. People are always like, well, it's A, B, and C because you read it, A, B, and C. But 5 is the hypotenuse because it's the longest side. So it's going to be C. And then the rest of them, A and B, it doesn't matter. I just always pick A and B, the first two ones that I see. Or A comes first, B comes second, but it doesn't matter. So I have a squared plus b squared is equal to c squared. Well, a is 3, b is 4, c is 5. I'll tell you right now, 3 plus 4 is not 5. But that's not how this works. A lot of people would say, well, 3 squared plus 4 squared is 7 squared. And that's not true. Hopefully you can do this kind of like these next few steps in your head. But 3 squared is 9, 4 squared is 16, 5 squared is 25, or you can just kind of like do those like all together. So you could do 3 squared plus 4 squared in a calculator. You wouldn't have to separate it out. Like you can just do, okay, well, what's 3 squared plus 4 squared? Okay. All right, and what is 5 squared? And are those two sides, is the left side and the right side equal? And they are. They both are 25, so yes, it is a right triangle. And that's how you can determine. You're just going to plug them in and see if it works. If you feel confident, please just watch this next one, just to make sure that you're really getting everything. So here we go. Are sides 10, 7, and 6 sides in a right triangle. I feel like that grammar was really wrong, but yeah, okay, whatever. Are those three sides actual sides in a right triangle? Are they like an acute triangle or an obtuse triangle? What I need to do is I'm going to plug them all into the Pythagorean theorem. It will not work. I'm just going to grab this random piece of paper. It will not work if you do it this way. This is not correct. This is not correct. This is not correct. This is not correct. Why not? Because 10 is the biggest, and the biggest number needs to be your C, or your hypotenuse. So 10 is your hypotenuse, because it's the biggest, and therefore it's C. And then this is A and B. It doesn't really matter which one you pick to be A or B, as long as it's 7 and 6. So then we're going to plug it in. A squared plus B squared is equal to C squared. What's my A? I chose it to be 7, but if you pick 6 to be A, that's fine. As long as you pick the other one to be B, it really doesn't matter. But no matter what, this is the non-negotiable. 10 has to be C, or has to be the number that's on the right-hand side by itself. And then we're just going to, you can plug that in your calculator. Again, if you kind of want to skip this next step, you can do it in your calculator. You can say, well, 7 squared plus 6 squared is 85. And I already know what 10 squared is in my head. That's 100. So no, it is not a right triangle. And that's your answer. Your answer would be like yes or no. And the answer would be no there. So here are two. Here's like example 3 and example 4. And I'll give you a second to like write these down, pause the video, try it on your own, and see if you're ready to go. 25, 18, and 20. 144, 145, and 17. So you're going to plug those into the Pythagorean theorem and see if it works. I'm going to quietly be working in the background, so if you do need to kind of peek up at me, you can. My A's and B's don't matter. I just always pick A's the first one I see. And plug it in. I'm going to use my calculator for this. I'm not even going to like type in what 18 squared is. I'm not even going to do that. I'm going to type in what 18 squared plus 20 squared is. And that's 724. And I do know what 25 squared is, and I know that it's not 725 or 724. It's 625. Nope. Those three numbers might make a triangle. Like if I was to make a triangle with sides 25, 18, and 20 would make a triangle, but it wouldn't necessarily make a right triangle, so no. And again, I'm not even going to type in 144 squared by itself. I'm going to type in 144 squared plus 17 squared, and that is 21,025. And guess what? I think, oopsies, I was right. Yep, so 145 squared is also 21,025. So yes, if I was to create a triangle with these three side lengths, they would end up making a right triangle.